Hello everybody, welcome back to the channel. So today we're going to deal with a very interesting problem. It is outlined as given that f at x equals to x squared minus 5x plus c. Then we have to determine the value of c if it is given that the solution of f at x equals to 0 are 5 plus minus square root of 41 divided by 2. So the first step in solving this equation is actually knowing that the solutions is our x equals to 5 plus minus square root of 41 divided by 2, right? This is the first step in understanding what the direction are saying. They say given that the solution of f at x equals to 0, I 5 plus minus square root of 41 divided by 2. So from here, we're actually going to solve this problem in a very interesting manner. We're going to literally go back. We're going to literally take it in reverse. All right? Very interesting, I know. So in doing that, I'm going to break this side down. I'm going to break this side down. And you have to be with me when I'm breaking that down because it's a very interesting problem. So I'm going to just do a cross multiplication. So obviously when you have a value that it doesn't have any denominator, you have to always imagine, always keep in mind that it is always divided by 1, right? So from here we're going to do what we call cross multiplication. We're going to do cross multiplication. So x times 2 is 2x equals to 1 times 5 plus minus square root of 41 is exactly as it is. So it's going to be 5 plus minus square root of 41, right? Yes, very interesting. Let me just take it to yellow because it's quite bright, right? Then from here, what we're going to do is take this value to the next side or to the other side, and you always have to keep in mind that when a value is being transferred or taken to the other side of the equal sign, it always changes the sign. So we're going to have 2x minus 5, since it was a plus, equals to plus minus square root of 41. This was a square root. I hope it was clear. It was a square root here. I hope it's clear, right? I hope it's together. So the next step is quite interesting. It's quite interesting because that's when you have to like know your laws of exponents, right? So the next step, I'm going to square both sides, right? So that I can cancel out the exponent. So what I'm going to do is I'm going to square both sides. What you do on the left, you must do on the right. I'm going to square both sides, right? I've squared both sides, and then when I square both sides, these ones they cancel, this they cancel, and we have 41 this side. Very interesting. And then from here, this is going to stay as it is. It's going to be 2x minus 5 squared, right? We're together, right? It's very interesting. Then from here, we're going to break this square. We're going to simplify this expression, right? We're going to simplify this expression. And obviously, when a term is squared, it means that it's 2 terms. So it's 2x minus 5 and 2x minus 5 equals to 41. Very interesting. Then here on this side, we're going to apply the FOIL method, right? We're going to apply the FOIL method into this problem, and then we're going to simplify it, and we're going to break it down. We're going to actually break it down to a more simplified version. So in applying the FOIL method, I hope all of you remember, we take the first, and then we take the outer, and then we take the inner, and we take the last. So in taking the first, is 2x times 2x is 4x squared, right? And then we're going to take 2x times negative 5, it's negative 10x, and then the inner negative 5x, negative 5 times 2x is negative 10x, and then the last it's negative 5 times negative 5, it's positive 25. Right? Then all of this equals to 41. I hope we're still together. Right? And from here, after we broke the factorized two binomials, now we're going to take the like terms and add them together. And in this regard, we have two like terms, that is negative 10x and negative 10x. We're going to add them together and it's going to give us negative 20. Obviously, they have the same sign, so they're going to be added together. So it's 4x squared, negative 10x, negative 10x is negative 20. You are adding now because they have the same sign. Negative 20x, then plus 25 equals to 41. Right? So from here, we're going to take this term to this side, right? And then we're going to simplify this term on the next step. I hope it's together. We're going to take this term to this side, so it's going to be 4x squared negative 20x plus 25. When you take a term to the next side of the equation of the equal sign, it changes the sign. So it's going to be negative 41 equals to 0. So obviously we have like terms in this regard. So there are two values that are not the same, but then they are for the 0th degree. Obviously we know that these are the same, they have the same base, that is to the exponent 0, so don't worry about that, we'll learn that next time. But then they are the same, they are numbers in this regard. Then we're going to add them or simplify this two expression or two terms. So it's going to be 4x squared negative 20x. 25 minus 41 is going to give us negative 16 equals to 0. Then from here, we're going to divide the whole terms by this coefficient 4. We're going to divide through by 4, and also on this side by 4. So we're going to divide the whole equation by 4. And obviously, we know 4 divided by 4 cancel each other. It's going to be x squared. And then this right here, 20 divided by 4, it's negative 5x. And negative 16 divided by 4 is going to give us negative 4. Then it's going to be on this side 0 divided by 4, anything divided by anything, or 0 divided by anything, it's 0. Yes. So then the next step, right, the next step is quite interesting. We're going to go back to the original question. I hope it's together. We're going to go back to the original equation. The original equation said determine the value of c, right? And then if it is given that the solution of f at x equals to 0. So I'm going to take that bottom solution to this top part so that we can be able to see what is happening or what's going on. So I'm going to take this portion, I'm going to copy it and take it up here. right up here. When I take it here, let me just minimize it and put it on this very end. Then what is going on now? What is going on now? I'm just going to write a simple line so we can divide what's going on this other side. So we have this solution that we got at the bottom, and then they said f at x equals to 0, which is this side, right? Let me just write down the equation. So I'm going to start with this part and write the equal sign on the other end. So it's x squared minus 5x plus c equals to f at x, whereby f at x equals to 0, right? So you're going to have, just put it this side, we're going to have x squared minus 5x plus c equals to 0, right? And then when we look at this equation and this equation that we got from the whole solution, we see there's a similarities within them. So this is how we're going to get our c. X squared is here, as you can see, and negative 5x squared, x is here, negative 5x is here, and plus c is negative 4. So as you can see, you can deduce from this equation that we got from taking back what we have got as a solutions from this. We can deduce that our c equals to negative 4. And that's your solution, that c equals to negative 4. As simple as that. I know it's very tricky. It's a very tricky question, but then if you go through it again, you will actually realize it is quite simple. So don't stress it. Just go through it again, and then you realize that it is very much simple to get.